to be 2. 1 plus 2 times 5. And this one, multiplication, is the top one. So that does this next. 2 times 5 becomes 10. I rewrite it again. And then 1 plus 10, addition, is the lowest thing. And that's how we end up with 11. And so that's how I would do these problems if I ever saw the problem on an exam. And it's a fun problem to put on exams because there is one and only one answer, and every programming class has usually at least one slide about this stuff. So like I said, the rules go top to bottom, parentheses, power, multiplication, addition, and then left to right within it. So we talked about variables and computing values to put inside variables, but the one thing you've kind of also, maybe you noticed it as we go by, is we have different kinds of data. We call it type. Is this of type integer? Is this of type floating point number? Is it of type string? What is going on here? And Python is pretty smart about various kinds of types of data. And so, we're adding 1 plus 4 here, and Python knows as it looks at this that that's an integer and that's an integer, and we'll add it together and make it an integer. So that thing is an integer. We can also use this plus to concatenate two strings. This is hello blank plus there, and plus looks here, says, oh, that's a string and that's a string. So I know what to do with strings. I will concatenate those two things together so it becomes another string that gets assigned into E, and it's hello space there. The plus doesn't add the space. I added the space by putting it right there. And so these operators are kind of smart in that they kind of know what they're dealing with, and sometimes they will do one thing or another depending on the kinds of values, variables, or constants that they're working with. And so sometimes type can get us in trouble. So here we have E, which is hello there because we've concatenated these two strings together. And now we're adding 1. And the problem now is that it looks on one side and says that's a string and that's a number and says, I don't know how to do that. This is another one of those annoying errors that you think that somehow Python doesn't like you, but it just is confused. If you look at these things, traceback always means I quit. It means I stopped, I ran, I'm quitting now because I don't want to go any farther because I've become confused. So your program stops running and you say, here's where I stopped running. Because we're typing interactively, it's always line 1 here. Type it, but if you read carefully and you don't get too stuck on too much stuff, line 1 that tells us something in module type error, can't convert int object to str implicitly. So that's an integer right there, and that's a string, and that's what it's complaining about, that little bit right there. If Python is so grumpy about types, then we should be able to ask it about types. So there turns out that there is, inside Python, a built-in function called type, T-Y-P-E. So we can pass into type. So the syntax is calling a built-in function named type, parenthesis is the parameter that we're passing to it. We're saying, hey, hello, tell me something about the type of the variable E. And so this is a function, the parentheses are part of the function call, and it says, oh, that would be of class string. And then we can pass in a constant and says, hey, what about hello? The string hello, it's like, oh, that's a string too. What about a 1? Well, that's an integer. And so we are asking Python through the type function what the type of either a variable or a constant is. And there are even several types of numbers, and we'll even see Booleans and others later. Like 1 with no decimal, that's an integer number. 98.6 with a decimal, that's a floating point number. And so, constants can be both integer and floating point. And I'm just asking over and over and over again, what is the type of what's in XXX, what's the type of what's in temp, and what's the type of the constant 1, and what's the type of 1.0. You can also use a set of built-in functions like float and int to convert from one to another. And so this basically says, I want to convert, let's go back. I want to convert 99 to a floating point number. So this is a function and it's participating in this plus, but before it can finish the plus, it turns this into a 99.0. The difference between 99 as an integer and 99.0 is that it's a floating point number, and that actually turns this computation, as it looks to the left and looks to the right, says, oh, I've got a floating point number on one side and integer on the other side, and so I'm going to make my calculation overall be a floating point calculation. I can also pass into the float function. I can say, take this variable I, which has a 42, also an integer, and then give me back a floating point. So that'll be 42.0. Pass that into F. We print it out, and it is indeed 42.0, and it's a float. And so it knows the type and value in any variable. This is an integer, a value 42. This is a float, a value 42.0. Integer division in Python 2 was kind of weird, and it was actually one of the big things that they changed between Python 2 and Python 3. This is a Python 3 course, so we're not worried about that too much. What's nice about integer division in Python 3 is it always produces a floating point result. And that means that Python 3's division is more predictable, and it works more like a calculator. So in this case, I mean, you can go back and look at my Python 2 lectures and see how crazy it was in Python 2. 10 divided by 2 is 5.0. And the weird thing here is these are both integers, but the division forces the result of the calculation to be a floating point number. And this, 10 over 2 could be 5, but 9 over 2 is 4.5. And so that is accurate. In old Python 2, that would give us back 4, which is completely unpredictable and weird. The same with 99 over 100. As you would expect, if this were a calculator, you get 0.99. Actually, what you get in Python 2 is 0, because it would round it down. It doesn't round at all, it truncates it. So 99 over 100 is 0.99, and then it truncates it to 0. That's Python 2. We're not talking about Python 2. There's a good reason we're not talking about Python 2. Welcome to Python 3. Of course, if there are a floating point on either side, the result is still a floating point, and the result is still a floating point. So integer division produces a floating result in Python 3.0, not in Python 2.0. That is an improvement in Python 3.0. And that's why we're recording these lectures. I have a whole great set of lectures about Python 2, and now I'm going to have a great set of lectures about Python 3. Welcome to Python 3. Okay, so we've been talking about converting from integer to floating point, but you can also convert from string to integer or string to floating point. And so here we start out with a little string value. Now it only works for strings that are made of digits. So quote 1, 2, 3 quote is not an integer. It is a 3-character string that has 1, 2, 3 as the characters in that string, which is very different than 123. We say, what is the type of this? It's a string. We say, let's add 1 to it. And it says can't convert into string, so that blows up, right? Because this is a string. It looks to both sides. String plus an integer, not good, okay? But we can convert this. We can call the int function, which is like the float function, and pass a string in. So it says, hey, take this and turn it into an integer. So take the input of sval, which is the string 1, 2, 3, and give me back an integer representation of that, which is going to be 123. So we say, what kind of thing do we get back? Well, we got back an integer. We can now add 1 to it and get 124. And so you have to manage the type of things, and you can convert from one type to another. Now, int is not magic. If you send something into it, a string that doesn't consist of digits, then you're going to end up with another error. Invalid literal for integer with base 10, blah, 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 blah. So it's really complaining. It says, I want these to be numbers here, and you just gave me letters, so that's going to cause this to fail. Another thing that we're going to do with variables is, just like the print function takes something, a list of things, in this case, a string, comma, a variable, and then prints some output in the program, the opposite of that is input. Actually, input generally happens before output. Input is a built-in function, and we pass to it a prompt, a string of text that's going to be printed out for the user, and then it stops and waits. So it says, who are you? And then right here it just sits, waiting for us to type something. So we type blah, 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 and then hit the enter key. Right? We hit the enter key, and then this text ends up in this variable. So this is an assignment statement that Chuck is the result of the input call, gets copied into the NAM variable. So let's do that again. It's evaluating an assignment statement. Remember, it's kind of this way, or you can think of it as just do this right side first. It writes this out, writes that out, then it waits, wait, until we hit the enter, and takes this Chuck, and that becomes the result of this input, which is then assigned into NAM. Now then we go sequentially to the next line. It prints out welcome, comma, contents of the variable NAM. Now this comma here actually does put the space in here automatically, so it says welcome space Chuck. So it pulls there's no space in Chuck, just the CHUCK. And so print